Have you ever stopped to ponder why ice, the solid form of water, floats on its own liquid form? It's a question that might seem simple at first, but trust me, it's anything but. You see, water is a bit of an oddball in the chemical world. Most substances get denser, their molecules packing closer together as they transition from liquid to solid. Water, however, dances to a different tune. As it cools, it does become denser, but only up until a certain point. Once it hits 4 degrees Celsius, it flips the script. It starts expanding, its molecules forming a unique pattern that takes up more space. And when water freezes into ice, this pattern becomes even more pronounced, making ice less dense than liquid water. That's why it floats. This seemingly simple question opens the door to a world of fascinating science. To understand why ice floats, we'll first need to understand how it forms. The transformation of water into ice is a fascinating process that begins at the molecular level. As we know, water is made up of 2 hydrogen atoms and 1 oxygen atom. These atoms don't just sit still, they're constantly moving and interacting with each other through something called hydrogen bonding. Hydrogen bonding is a type of attractive force that occurs when a hydrogen atom bonded to a highly electronegative atom, like oxygen, is attracted to another electronegative atom in a different molecule. In water, this bonding results in a network of molecules with a slight positive charge on the hydrogen side and a slight negative charge on the oxygen side. Now let's imagine we're gradually cooling a glass of water. As the temperature drops, the water molecules start to slow down. When the temperature hits 0 degrees Celsius, something amazing happens. These slowing molecules begin to arrange themselves into a specific pattern, a hexagonal lattice to be precise. This is due to the hydrogen bonds aligning in a way that maximizes attraction and minimizes repulsion between the molecules. This hexagonal structure is unique to ice. It's like a 3D honeycomb, with each water molecule forming hydrogen bonds with 4 others. This arrangement creates a lot of empty space, or holes, within the structure. These holes are the reason ice is less dense than liquid water. You see, density is a measure of mass per unit volume. The hexagonal lattice of ice spreads the water molecules out, occupying a larger volume than the same number of water molecules in a liquid state. Therefore, even though a block of ice and an equivalent volume of water have the same mass, the ice takes up more space, making it less dense. So, the unique structure of ice forms due to the properties of water molecules themselves, leading to its ability to float. This fascinating process, from hydrogen bonding to the formation of a hexagonal lattice, is what allows us to enjoy phenomena like ice floating on water. Now that we've understood how ice forms, let's delve into its properties. Ice, like the water it originates from, is a versatile and remarkable substance. Yet it's distinctively unique in its characteristics. One of its most striking properties is that ice has a lower density than water. This might seem counterintuitive, since we typically think of solids as being denser than liquids. However, the crystalline structure of ice causes the water molecules to spread out, making it less dense than its liquid counterpart. This characteristic of ice is more than just intriguing, it has profound implications in nature. The reduced density is why ice floats on water, a phenomenon we often take for granted. But imagine for a moment if ice sank instead of floated. Lakes, rivers, and oceans would freeze from the bottom up, making it impossible for aquatic life to survive in colder climates. This floating layer of ice creates an insulating barrier, preserving a liquid environment beneath, even in the harshest of winters. This allows life to continue existing under the frozen surface, from tiny microbes to larger aquatic animals. So this seemingly simple characteristic of ice floating on water is what helps sustain a vibrant ecosystem beneath the ice. It's a testament to the fact that the properties of ice are not just fascinating, they're crucial to life as we know it. The world of ice is more complex and intriguing than it first appears. We've journeyed through the formation of ice, delving into its unique crystalline structure that gives it an array of distinctive properties. It's this very structure that enables ice to do something quite remarkable: float on water. So next time you see ice floating in your glass or on a lake, remember there's a world of fascinating science behind it.